Hello, and welcome to a series of lectures on cis204 Unix shell scripting and utilities. This is the week 2 lecture, and it's on Unix history and processes, files, and a little bit on Linux, but basically it's going to be a personal history of Unix. I've divided today's lecture into 3 parts, each of 20 minutes in length, so that it's easier to digest. Basically, it's also easier for the slow computer to digest. But be that as it may, what I'd like to do to begin with is show you a little bit about the machine I'm running on. It's a Samsung laptop, and it initially came with Windows 8, but now I've got it running Ubuntu 15.10. I didn't have Windows 8 on it for very long before I decided that I would actually give up my license for Windows 8 and use Ubuntu exclusively on it. Normally, I would dual boot a machine like this, but in this case, Windows 8 just didn't agree with me, so Ubuntu it was. It's been updated a number of times, as you can see, and it's running Ubuntu 15.10, 8 gig of memory, 2 very slow Pentium CPUs, but it is a 64-bit machine with about 500 gig of hard drive. The Ubuntu image is actually pretty stable. It's a good device, and I've had a great deal of success running Ubuntu. I like it a lot. But let's get right into a personal history of Unix. Also, we'll discuss processes and files. So, this is an interesting picture. Bell Laboratories. There are 2 gentlemen in the picture, and I use the term gentleman loosely. You'll notice the big machine. That is a Digital Equipment Corporation DEC pt1. The gentleman sitting down is Ken Thompson, and he's got his hands on a TTY-35, Teletype Corporation. Notice it has the exposed keyboard, what appears to be a hump, and a roll of paper. That's it exactly. This was line at a time processing. The gentleman standing over Ken Thompson's shoulder is Dennis Ritchie. These 2 are responsible for Unix. They gave the impetus for what became Linux, and they were a couple of characters. Unix started with a project that was a group of companies were building an operating system that was to be called Multics. Ken Thompson and Dennis Ritchie were assigned to this project from Bell Laboratories. And Thompson had built a game called Space Travel, and it ran in Multics. Now, Multics was typical of the operating systems of the time. It was built using assembler. The code, the OS, the operating system code, was built for the specific set of hardware, and that code was in the assembler language or the assembly language that was specific to that set of hardware. Every hardware set basically had its own assembler. So when Multics folded, and it was pretty much a routine of when you've got a group of companies together, they each wanted certain features, and all of a sudden the operating system was no longer simple. So what they ended up with was too many cooks spoiling the soup, and the project was canceled. And Ken Thompson, sitting there, had no place to run his game Space Traveler. So he needed to create a new OS, or to find a way of porting the existing one into an existing machine, this PDP-7. And they ended up doing that in the late 1969, early 1970 time frame. And it wasn't named at the time, but later it became named Unix, UNIX, and I spell Unix all caps, which is the way it initially was spelled. If you run into any stories about the origin of the name Unix, you can believe them. It is a pun. It is a double entendre. It is exactly what you expect it to be. Um, Basically, Thomson skinnied down the bits and pieces from Multics that he wanted to use and created UNIX, and he was able to run space travel on it. At some point, he decided he wanted to run it just a bit faster than he was doing. So they conceived the notion that they could do text processing with this new operating system called UNIX, and that would free up a lot of time and effort in Bell Laboratories. And this was all in justification for picking up a brand new PDP 1170. So basically what happened is UNIX was born out of Ken Thompson's necessity to find a new operating system for a game that he was playing. Eventually, what happened with UNIX is, yes, the original code was written in assembler to interact with the hardware, but what they found is they could limit the amount of code they needed to run or build in assembler, and they used a programming language called C, which, by the way, Bell Labs wrote. They found that that programming language allowed them to build other aspects of the kernel that did not require specific assembler instructions. So what happened is this. Small bits of the code had to be written in assembler because of specific hardware requirements. Other pieces of the code could be written in C and were therefore portable to any other machine that had a C compiler. So this basically allowed the operating system, now known as UNIX, to expand to multiple different computing devices. It was no longer restricted. As a matter of fact, for a long time we had an Amdahl V8, which was a mainframe, running a version of UNIX on it. This was basically an MVS mainframe. The Amdahl V8 would run UNIX or MVS. There was a copy of UNIX that was actually compiled to run on a mainframe. So at the time, it was kind of amazing. This new kernel that had quite a bit of it written in C made things work really well. What I'd like to do now is open up a quick video, and this doesn't really show how big these characters actually were, but it gives you a clue as to who they are and what Bell Labs was trying to do with this system.
Back in 1969, a couple of computer scientists here at Bell Labs started to develop some programs they needed for their own use. What Ken Thompson and Dennis Ritchie started developing then has evolved into the UNIX operating system, which by now is widely used around the world.
We were trying to make computing as simple as possible. In the late 1960s, Dennis Ritchie and I realized that the then current operating systems were much too complex. We attempted to reverse this trend by building a small, simple operating system on a mini computer.
Well, what we wanted to preserve was not just a good programming environment in which to do programming, but a system around which a community could form, fellowship. We knew from experience that the essence of communal computing, as supplied by remote access time-sharing systems, is not just to type programs into a terminal instead of a key punch, but to encourage close communication.
The UNIX system started out as a two-man effort, and by now it's used all over Bell Labs. We have close to 20,000 computer terminals in this company, roughly one per employee, and most of them are used for communicating with UNIX systems. One of the main reasons the UNIX system is popular around here is because it provides graceful facilities for decomposing complex computing tasks into simple subtasks.
The UNIX operating system.
I'm pausing right now to let you know that what you're about to see is important. This explains how the UNIX kernel is built, basically. Well, it doesn't explain how it's built. To do that, we'd be talking about graduate level programs. But this will give you clues to how they conceive the UNIX kernel and the shell.
The system is basically made up of three parts. The kernel, or operating system proper, is the part that manages the control of the machine and supervises scheduling of the various user programs. The shell or which is the name we give to the command interpreter, looks after the communication between the user and the system itself. The third part, which is actually the largest, is the various utility programs which perform specific tasks like editing a file or sorting a bunch of numbers or making a plot. In other words, all the other programs that are not provided directly as part of the operating system kernel.
So there you have it. Ken Thompson and Dennis Ritchie. And that really short-sold what these guys were like. That film was made in 1982. There was really never a commercial version of Unix that came out of Bell Labs because AT&T was not permitted to build and sell computer hardware or software. So we'll get into that in just a bit. But Thompson and Ritchie did not come across in that film as the characters that they truly were. How goofy were they? Well, one of Thompson's favorite films has been described as the worst film ever made, and it's a hoot. It's just more fun to watch and laugh at than almost any other film made, and that's Plan 9 from Outer Space. He liked it so much that their follow-on operating system for Unix was called Plan 9 from Bell Labs. Here in front of you is the Unix family tree. And I'm going to expand this just a bit so that we can take a peek at, in a little bit better way, where it all started. So in about 1969, there was that follow-on to Multics, which was an unnamed operating system running on a PDP-7. At some point in the early 1970s, they decided to call the operating system Unix. And you notice here that they've not used the all caps version, Unix. So there's Unix version 1 through 6 basically came out. At some point, Bell Labs decided that they would license this product, this new Unix, to schools, basically universities. They weren't allowed to charge for it, but they could license it. And one copy of that license went to the University of California in Berkeley. And that led to Berkeley Systems Development, software development. And that led to a flavor of Unix called BSD-1. And that went to all the way up to BSD 4.3, various versions of that. The labs continued to build Unix versions. They had a Unix version 7, which you can see was picked up and used as a basis for a product called Xenix, which was written by Microsoft. That product actually existed, and at one point I actually had a machine at work that was dual booting Xenix and DOS. The other place that product went to is eventually it created a Unix 32V, and that gave rise to the first version of HPUX. Unix version 7 and Unix 32V gave us System 3 and this PWB Unix. The System 3 Unix became System 5, Release 1 to 2, Release 3, and then eventually the commercial Unix, System 5 Release 4. And why did I say that's commercial? Because that product occurred after the consent decree of 1984. Basically, the Bell system was split up in 1964. You can see that Microsoft product, Xenix, eventually became SCO Xenix. And SCO got their hooks into things later on because they created this SCO Unix 3.2.4 and then claimed that other companies were infringing on the copyrights of their product. In particular, if I don't scroll too quickly, I can show you this AIX 1.0. That was IBM's version of Unix. Came out of BSD 4.2, came out of Sys5 Release 1. Another tool that came out was SunOS, which was BSD's 3.0 to 4.1. that became that gave rise to SunOS. SunOS eventually, along with cis5 release 4, gave rise to Solaris. So all of these various tools grew up. These various versions of the Unix OS grew up and came basically from, at one point, the very first version of Unix. Now, on the other side of this, you'll see BSD gave rise to Next Step, OpenStep, and right over here, BSD 4.4, there's Mac OS X. Interesting. Well, if you look behind the covers of the Mac OS, it is basically a Unix variety. And then here we've got Linux 0.0.1, and that is in the 91 time frame. This Minix is a miniature version of Unix. There's another tool, another OS that's not shown here, amongst many other OSs that are not shown here, and it was Silicon Graphics IRIX. Many of you remember Pixar. Pixar used Silicon Graphics machines quite a bit, and the operating system there was IRIX. So, to the personal part. Let me go back up here, and I'll wander back here. The first version of Unix that I ever used was in 1979, and it was either Unix version 5 or 6. I was in a switching control center working for Southwestern Bell, and the switches, the electronic switching equipment that we had was watched, monitored, and controlled by a couple of DEC PDP 1170s, and they were running Unix System 5 or 6, and I don't remember which one it is. I've used Solaris, I've used Xenix, I've used SunOS. In fact, I had a Solaris System and Networking Administration certification at one point in my career. I've used BSD on a number of occasions. I've used AIX as little as I could get away with. I've used HPUX more than I wanted to. Solaris and BSD variants, the Berkeley variants, are my favorites. A lot of cis5 release 4. So, let me go back and make this fit the page here. And remember, in the video, it talked about hardware, the kernel, the shell, and application programs. The hardware are the bits and pieces, the disk drives, the monitor, the keyboard, the mouse. Those types of things are all require device drivers to make them work. The kernel supplies the glue that ties the various hardware pieces together and also animates them, basically. The shell is our interface to the kernel. And in this particular tool, you'll see that bash, K-shell, C-shell, shell show up. SH was the original shell. C-shell came out of Berkeley, actually Berkeley, Stanford. K-shell is the corn shell, my favorite. And bash is the born again shell. The original shell was the born shell. Bash is the born again shell. Here we see various utilities, actually commands: more, page, which, env, cut, ed, vi. Ed and vi are editors, and we'll talk more about those next week. And then the shell. And the application programs are mail, browsers, the FTP, any GUI basically that you might work through, and the DBMS. These are all part and parcel of Unix. So, this is the first part of 3 parts of the personal history of Unix, Linux, files, and processes. When we come back, we'll start talking about the file system.